Okay, it looks like we have a quorum now. I'd like to welcome everybody to this speaker series seminar. And everybody listening in, this is the first of the year, so congratulations. Tonight we'll be hearing from Dr. Ed Wolfe, who will be speaking this evening about water, which is becoming an increasingly scarce resource in many parts of the US. It's a topic we're certain to find interesting. Looking forward in the coming months, we'll have a full slate of speakers on the agenda. Next month, we'll be hearing from Red Rock District Ranger Amy Tenderholt. And then in March, author Lisa Schnebbe-Heidinger is on the agenda. But this evening, those of you listening in on this evening's webinar will be given the opportunity to ask questions of the guest speaker after his conclusion of the formal presentation. So please use Zoom Q&A. It's the feature located at the bottom of your Zoom window. Please do not use chat. At the end of his presentation, our speaker will answer your questions. Now I'd like to welcome Dr. Ed Wolfe to discuss our water, an increasingly scarce resource. Ed?
Hi, glad to be here. So I made a slightly different title for my talk. It's called Water in the Prescott and Upper and Middle Verde Regions, a Diminishing Resource. And I'm looking forward to giving the presentation and then talking with people. Just a word about the Citizens Water Advocacy Group. That is a Prescott area science-based citizens group that was founded in 2002. I actually was a part of the first board of CWAG, and we founded it in response to learning about the growing water issues, the concern about future water issues in the Prescott region and on the Verde River. I might add that I did a lot of things in my career as a geologist, but among them I spent a number of years in Flagstaff working on geology there. And I also studied the geology, if you like, of the Cedar Bench wilderness, which is down in the southern end of the Verde Valley and in the Black Hills to the southwest. So we face two fundamental challenges. One, our water supply, especially in the Prescott area, is dependent on groundwater. We're depleting our groundwater reserves because we pump too much. Excessive groundwater and climate change are reducing the flow of the upper Verde River, and that, of course, affects the rest of the river. So just a few slides for people who don't speak groundwater at all. So the first thing is to look at some groundwater, which we see in this hole. Now this happens to be at the beach, and in this case, the groundwater is salty. Nevertheless, it's groundwater, and sometimes fresh water comes clear out to the edge of the ocean. I lived in Hilo, Hawaii for a number of years, working as a geologist on the Big Island. And after playing tennis, my wife and I would go to an area along the coast near Hilo and swim, and there were freshwater springs flowing into the surf zone, which was kind of neat. So the top surface of the water, whether it's here probably 6 inches or a foot below the ground surface, or whether it's several hundred feet below the ground surface, is the top of the aquifer. And the aquifer is a geologic unit. Could be sand and gravel, it could be rock with pore spaces in it, but that is entirely filled with water. And so below the water table, the sediments or rocks are completely saturated with water. Above it, you would find some water stuck in voids, but it wouldn't be continuous. Here's a cartoon of that kind of thing. So we have surface water on the right here. It could be a stream. It could be the Verde River, and it's flowing through in this case, what looks like a deposit of sand and gravel. And you see that the top of the water table separating the zone that's saturated with water, which is the aquifer, from the unsaturated zone, which normally isn't completely devoid of water. It's just that the water is not continuous in the void spaces. Here's a cartoon of a simplified alluvial basin groundwater system. The Verde Valley is an alluvial basin. It's a downfaulted basin. It looks kind of like the diagram with cross-section here with relatively impermeable bedrock on the sides, at least in places. It's filled with sediment, several thousand feet of it in places. And water runs off the slopes. It seeps in during storms, and it works its way down to the water table where it's stored, except the storage is temporary because that water is always moving, and it moves in a downhill direction. So in this case, it's moving through the aquifer. You see the aquifer sign and the arrows. The aquifer has to be sufficiently permeable with the pore spaces connected so that it can store and transmit water. Streams move, and this aquifer, this water in the aquifer, the groundwater actually intersects the ground surface there where all that green vegetation is, and that's what goes on in most of the Verde Valley, where the Verde River, at the Verde River, it actually, for most of it, but not all of it, actually intersects the water table. I might, just to help you grasp this a little further, say that, you know, streams travel at commonly a mile or a few miles an hour. Groundwater is flowing through a very broad area, but it's flowing at a much slower rate that might be measured in terms of feet per day, just to give you some contrast there. We're going to just move over to the Big Chino Valley, which is a critical subject with respect to water in this area. So the yellow area with the blue contour lines that takes up most of the picture is the Big Chino Valley. I don't know whether you can see the mouse. I'm using it to show the Big Chino Valley. What do you guys say? Guys, can you see the mouse, the arrow?
Mm-hmm.
Yeah,
Oh,
we can
great.
see it, Ed. It's
Wonderful.
there.
Okay, so this is the Big Chino Valley right here. This is the Little Chino subbasin in the Prescott area. The yellow stuff is the top of thick alluvial fill deposits, which get to be at least as deep as about 2,500 feet in kind of the deepest part of the basin, which is in here. The contours, these are contours. The values on the contours are in feet, and they are contours drawn on the surface of the aquifer, drawn on the water table. And those of you who are used to reading contours can see that they descend downward to the southeast from up here to down in this direction. And the arrows show the direction of groundwater movement in the aquifer. Groundwater movement in the aquifer is always perpendicular to the contours. So it moves downhill with respect to the top of the aquifer. Right down here at the kind of the lower right is the Polden stream gauge. And we're going to be talking about stream gauges a fair amount. And this is at about mile 10 or so on the Verde River. The headwaters, so the headwaters of the Verde River, the official headwaters, are up about here where the arrow is. And the USGS operates a number of stream gauges. One of them is the Polden stream gauge, which continuously measures stream flow. A really important thing to note here is that the groundwater uh, that passes the Paulding gauge, the base flow. Base flow refers to the groundwater component of stream flow. So stream flow is both runoff that's relatively shallow and not very old and gets to the stream and runs off. But what makes these streams flow all year round is groundwater that's intercepted the stream and is flowing in the stream. And we refer to that groundwater component as base flow. And the reason for that explanation is that the Big Chino Valley is based on some very detailed and exotic chemical work, is interpreted to about 80% of the Big Chino passing the Paulding gauge, of the water passing the Paulding gauge, comes from the Big Chino. There's no permanent stream in the Big Chino Valley, so it's coming from groundwater, and about 14% comes from the Little Chino. That only adds up to 94%, and there's another 6% of uncertain heritage. We'll talk about the Prescott Active Management Area because it's an important part of the story. In response to the Groundwater Management Act, a state organization taken on during the days when Bruce Babbitt was the governor, several critical areas where there were growing populations and limited water were designed as active management areas. So the Prescott Active Management Area is down here on the south side of this thing. This is this boundary, and we'll go into it in more detail, is the boundary of, I'm sorry, the boundary is here. There are two sub-basins, two separate, not separate, but connected groundwater basins, one draining to the Agua Fria River down at this end, and the other draining to the Verde at the north end. So one is the Little Chino subbasin, which is the northern one, and the lower one is called the Upper Agua Fria subbasin. This is the Big Chino subbasin, and this is the Verde Valley subbasin, and the towns in the Verde Valley, including Sedona, are in the Verde Valley subbasin. I must emphasize that these are surface water drainage basins. They are not groundwater basins. The groundwater basins are smaller, and we'll get to that. So this really from this edge of the Little Chino Basin all the way up here, which is up beyond Seligman, to down here, which is below Camp Verde, these are all topographic stream flow basins. These are surface water basins. Let's go to the next. This is a map. Well, just back up for a sec here. So next slide deals with this area right here, which is called the Prescott Active Management Area. And then this is a map of the Prescott Active Management Area, and it includes the aquifer and groundwater system that Prescott Valley, Chino Valley, and Dewey-Humboldt. Town of Chino Valley, Prescott Valley in this area, and the community of Dewey-Humboldt down here. The whole area of this Prescott Active Management Area is about 485 square miles. And the aquifer system, which you'll see in the next slide, occupies about half of that 485 square miles. The area of gray in this map of the Prescott Active Management Area is relatively impermeable rock. It's mostly granitic rock or metamorphic rocks like you see when you get up around Jerome and you drive from Jerome over the Black Hills toward Prescott Valley. if you get up high enough, you start to see some younger Paleozoic age sedimentary rocks and then some young volcanic rocks. But the rocks that you see in the steep country right above Jerome are these Precambrian rocks, which are on the order of about 1.5 to 1.8 billion years old. They're called Precambrian rocks. The arrows in this diagram are sort of a simplified display of the direction of groundwater movement within the aquifer. And so there is a divide that goes right through this area here. So north of that divide is what we call the Little Chino well, no, that's not correct. Little Chino subbasin is a topographic feature. These are groundwater, and the divide for the groundwater system is not in the same place. So the arrows show the direction of flow. So south of a line going right through there, the water flows to the Agua Fria basin and river, the upper Agua Fria, and it flows north to the Big Chino Wash. It's groundwater. You don't see it up here. It's in the subsurface, and it heads into the Big Chino Basin and then to the Verde River. The colored dots in here portray the change in water level over about a decade from about 1994 to 2004. So the occasional red dots like this one here and this one here, and there's one here, record decreases in the water level over a 10-year period, and they represent decreases that are greater than or equal to 30 feet in 10 years. If you've got a well and you're an individual homeowner with a well and it's going down at 30 feet in 10 years, you might start to be concerned. The orange, which are very abundant here, are wells, and these are monitoring wells that the Department of Water Resources monitors, and their rate of decline is between 15 and 30 feet over this 10-year period. So our water table is dropping. The aquifer is gradually getting emptied, and that's really the point of this slide. So for simplicity or to have few letters, instead of writing out Prescott Active Management Area, I use the term PRAMA, P-R-A-M-A, Prescott Active Management Area. And this is going to be a review of groundwater demand. It starts off with just information from 1985 to the present of estimated cumulative groundwater demand in the Prescott Active Management Area. So the orange or yellowy parts of each line is a year, starting 1895 and going through 2018. That's the last data we have currently from the Department of Water Resources. The orange lines represent the amount of water provided to people in the Prescott Active Management by municipal providers. Those are the cities, Chino Valley, Prescott Valley, primarily, and they're the biggest water consumers. And as populations have grown, as you see at the top of this yellow area of the diagram, the demand for water has increased. Now, this doesn't include surface water. This is just groundwater demand. The blue is exempt wells, and actually what each one of these, we're looking at the top of a category, and the bottom of each category is at the bottom of the graph. So this is labeled municipals plus exempt wells. So exempt wells are added in here. Exempt wells are small private wells, and there are thousands of them in the Prescott Active Management Area. And then above that, we've added industrial wells on top, and then agricultural wells. This is groundwater for agriculture. Agriculture, of course, in the past used a lot of surface water. A really important thing that's happened here in the Prescott Active Management Area is from 1985 through the present, agriculture has diminished, and municipal growth has increased. And so we see the municipal use becoming much greater than it was earlier, and the agricultural use falling off. We're going to talk quite a bit about an issue called overdraft, and that relates to the water stored in the aquifer. The overdraft is the volume of water lost from the aquifer, and you have an overdraft when the volume of water removed exceeds the volume of water returned. And before we all got here and started farming and then building cities or lots of homes and so on, in the long term, the water supplied to the aquifer by rain and snow melt and streams was in the long term equivalent to the amount of water removed from the aquifer. There are two processes that in the natural system remove water from the aquifer. One is it reaches the surface and runs off in a stream. It also flows as groundwater down toward where it exits to a stream. And I guess that's what I'm thinking of right there. So the Department of Water Resources, in trying to, for the Prescott Active Management Area, and it does this kind of thing for the other management areas, the really big one is the active management area in the Phoenix and Tucson region. Or I think there are actually two of them. So this is a data that they've generated starting in 1985. This is generated by a groundwater model. A lot of this cannot be directed. It cannot be observed directly, and it has to be, it's based on scientifically based inferences and calculations and so on to come up with the numbers. The blue lines, so right here where this sign 1996, there's a boundary between the red lines and the blue lines. The blue lines represent years in which more water was added to the aquifer than was taken out. Those were good years. Those of you who were here in 2005 may remember that right around the period between 2004 and 2005, at the turn of the year there, we had one whopping winter and days of rain or snow. The red lines represent individual years in which water was lost from the aquifer. The biggest losses are here in the mid 2000s, and they are more than 20,000 acre feet in a year. One of the things you'll see is that when you go from, I should back up and tell you what an acre foot is. Sorry. For some reason, hydrologists like to measure. I'm a geologist, not a hydrologist. I didn't know about acre feet for a good part of my life. But 1 acre foot is the amount of water that would stand 1 foot deep on an area 1 acre in area. And so that's the term we use here. I don't remember off the top of my head, and I'm not going to guess the size of an acre. I've known it and I've used it many times, but I don't want to guess it. So the blue lines then are areas of good precipitation, both snow and rain, and the red lines are our annual deficiencies, years in which the aquifer lost water. And I put this 1996 in here because there's quite a change that seems to take place around 1996, and I will refer to it in other slides. For the, I think 11 years prior to 1996, the average overdraft was about 2,600 acre feet per year. But from 1996 onward through 2018, the average overdraft was more than 13,000 acre feet per year. And we're going to spend a part of this exploration trying to understand what might be at work there. This is exactly the same data. In fact, the data you saw earlier is represented in this upper chart right here. And all I've done here is to turn this individual annual plot represented up here into a cumulative plot in which we just added each year's addition or subtraction in sequence. And you can see that here up until 1996, this thing kind of held its own. We didn't have anything extraordinarily used. The average annual overdraft during that period was about 2,600 acre feet. Starting here at about 1996, the rate of overdraft and the consistency of overdraft really gradually increased. And by 2018, the overdraft was approximately 1/3 of a million acre feet. So if you think of the size of your lot that your house is on, if you've got a big expansive lot, it might be an acre. The maximum size commonly in this part of the world is about 2 acres, not counting farms, that sort of thing. Just to give you an idea. I'm sorry, I don't have the number in my head right now. So the average overdraft had really increased and has continued to increase. And we're going to explore that by the cumulative overdraft 1985 through 2018. By 1985, approximated 1/3 of a million acre feet. That's a lot of water. And we live in an area with a growing population, and we're losing water really fast. So what on earth is going on? So here's a sort of a bigger picture. And I'm going to talk about 4 stream gauges here, 3 of them on the Verde River and the other on Oak Creek. So they are the Paulden stream gauge, the Clarkdale stream gauge, and the Camp Verde stream gauge, which are on the Verde, and the Sedona gauge, which is on Oak Creek. And just to refresh you on geography, the Verde River starts up about in here. This gauge is at about mile 10 on the Verde River. The Clarkdale gauge is just downstream from Sycamore Canyon. It's between Sycamore Canyon and Tuzigoot up north or west of Clarkdale. And then the Camp Verde gauge is actually about 13 miles downstream from Camp Verde. For those of you who've been down in the country, it's just above the mouth of Chasm Creek. And here you see these 2 subbasins in the Prescott active management is here. So sort of keep these gauges in mind as we go through the following discussion. Here is a record. It is not the entire flow record. It is a derivative from the flow record. These are annual, lowest 7-day annual flow And that's a kind of an arbitrary number that some people doing hydrologic reports have used. It's always interesting and challenging to try to understand when you are looking at a stream flow, what part of that stream flow is just normal runoff from melting snow or from rain, and what part of that is groundwater coming out of the aquifer and flowing into the river. And I find that I think it's a pretty mysterious thing how that is determined. So in these few diagrams, I have taken the year's record. I've taken the daily record, 365, or in leap year, 366, average flow records in cubic feet per second. And I have taken out of that, I have separated out all but the 7 that average adjacent records, continuous records that give the lowest flow, thinking if there's any part of the flow of the river that represents groundwater, it's likely in that relatively small. So that's what's called here 7-day annual flow. It's arbitrary. Maybe it should have been 8 days. Who knows? If the groundwater component in the river gets low enough, or the river gets used up, the river ends up being completely above the water table, then these rivers will be dry for a good part of the year. They'll flow when there's a heavy rain or when there's a significant snow melt. The Verde, if you don't count the Colorado River, the Verde is the only of Arizona's half dozen or so major rivers that still flows year round. And it flows year round because it has a component of groundwater that is sufficient to keep it flowing even during the dry periods. And that's a remarkable and wonderful thing about the Verde, and something we should treasure. So the blue dots represent for the period of record. So for the Paulding gauge, the gauge was installed in the mid-60s, and I have a record here that went through 2019. The 2020 record isn't quite ready yet. We see, so each dot represents the annual volume of the 7 consecutive days of lowest flow in the year. So that, if anything represents groundwater, that's likely to be it. If we use up enough of our groundwater, then the time when we had 7-day low flows, those would be periods when much of the river is dry. So they make a linear pattern. It's not a perfect one. I put in a best fit least squares trend line just to have a sort of a justifiable trend based on these values represented by the blue dots. I didn't know it was going to be this way, and none of the people I talked to knew we would get this results. But right about the mid-90s, there was a significant change in the trend of that low flow. It began to decrease. It was increasing, broadly speaking, from mid-90s to 1996, and then the annual low flow volume, 7-day low flow volume, began to decrease. And I thought, boy, that's interesting. And I got some doubting questions, but I think my colleagues in CWAG at least think it makes sense. So what I did here was, I have a statement here that says aggregated annual flow, low flow values, 1996 through 2019 are approximately minus 6,100 acre feet per year. These flows these dots are not completely, and they're not decreasing exactly the same. They may go up 1 year and down another. And so if you just look at the values, you have to do something to make them understandable. What I did then was to take all of these values from 1960 through 1996 and using Excel, subtracted one value from the next, and I ended up with a sequence of numbers that were negative and positive. So if the low flow value for 1 year was 25 cubic feet per second, and the next year it was 23 cubic feet per second, and I subtracted one from the other, I got either a positive or a negative numbers. And I added all those numbers together to come up with this aggregated annual low flow value, which in this sequence, in the Paulding gauge, comes to 2,900 acre feet. Similar process here when those 7-year flows began to decline, and the decline here by that same aggregating process was a negative 6,000 feet approximately. I didn't mean to click to the Clarkdale gauge, but this is the same thing. The Clarkdale gauge is about approximately 39 miles, mile 39 on the river. It's actually above Clarkdale. It's just a little bit below the mouth of Sycamore Canyon, for those of you who are familiar. I saw exactly the same pattern here. The numbers are the values for flow are quite a bit larger than they were at the Paulding gauge, because the river has grown from between the two gauges. And so here, the range during the time of increasing low flow was between about 20 and 25 acre feet per year. For the same period, that value at the Clarkdale gauge was between about 65 and 75 or 80 feet, 80 cubic feet per second, I should say. Again, I saw exactly the same pattern with a decrease through this sequence of measurements of about 5,800 acre feet. I'm sorry, an increase, and a decrease here from 1996 through 2019 of about 14,000 acre feet. So this seems to represent some kind of a real phenomenon that has to do with the apparent change in overdraft that the Department of Water Resources determined, and seemed as if it ought to have some meaning. The Camp Verde gauge has a much shorter record. The Camp Verde gauge is about mile 92 on the river. It's about 13 miles or so below White Bridge on the highway at the south end of Camp Verde. And it's down in getting into the very lower end of what you might call the Verde Valley. But we saw the same pattern, a decrease in 7-day low flow values from 1996 through 2020 of approximately 11,000 acre feet per year. I think that this short pattern is the same increasing, represents the same increasing pattern that we saw at the other two gauges that we've talked about. But it's a little bit short to be talking about a long-term trend. So I only did it for the declining trend. And I thought this was a really interesting thing. Oh, there was one thing that I should have said or wanted to say back when we were looking at the Paulding gauge and the Big Chino Valley. In fact, I'm going to say a couple of things that I would have said. Um, Prescott and Prescott Verde have an eventual water shortage issue. Prescott Valley is probably in a more dire strait than Prescott is. And they managed to get legislation passed in the Arizona legislature that permitted them to import groundwater from the Big Chino Valley to the Prescott Active Management Area. There was quite a legal wrangle about it within the last decade or so, and they ended up with an agreement that would let them import about 8,000 acre feet per year from what's called the Big Chino Water Ranch. And I had meant to talk about that. So think I'm way up in the Big Chino Wash, an area that the city of Prescott now owns, called the Big Chino Water Ranch. And they have a legal authority to extract 8,000 acre feet of water per year and import it to the Prescott Active Management Area. That has caused a tremendous amount of concern because we know when you remove groundwater from the aquifer, it reduces the groundwater contribution to a stream. And that removal, not immediately, but over a period of decades, would reduce the flow at the tiny little community of Perkinsville, which is at the very upper end of the Verde Valley, to zero or less. and I think that's an important thing to point out. So we would have a stretch of the Verde River from the Paulden Gauge down to Perkinsville. It's about 24 miles or so. That would be completely dry part of the year. So who cares? Well, that of course would reduce the flow in the Verde Valley and all the way down through the Verde River, all the way to where it empties into the Salt River after passing through SRP reservoirs. And it would make a difference. And it would just be a step in the eventual continuing decrease and maybe eventual demise of a significant part of the Verde River. But the part between the Paulden Gauge and Perkinsville would be gone fairly soon. So I did want to point that out. And I'm sorry I didn't think of it when I was there in this talk. So there's a gauge on Oak Creek at Sedona, and it's close to where the Schnebley Hill Road meets Highway 189. So it's pretty close to the big shopping center there at that intersection. And the pattern at that gauge doesn't look anything like the pattern at the other three gauges. I don't have a wonderful explanation about why that's the case. I have a guess. And I think the guess may be that the stream bed there is not far above the red wall limestone. And the red wall limestone is a super good aquifer in this area. Up in Flagstaff, it's pretty deep to be practical for most people, but it's a rock. It's a limestone with a lot of tremendous amount of void space in it. It actually has caves in it. You can see one on Highway 89A as you go over the hill between Jerome and Prescott Valley. You have to watch kind of closely for it, but you see a big opening and you see lots of little openings in the red wall limestone. So the red wall is a wonderful geologic unit for accumulating and transporting water. And I think it may be that this isn't seeing whatever, yet at least, not clearly seeing the effect of what's affecting the other gauges. I included it here just for it to be complete. Okay, so we have an overdraft, and we've talked about the overdraft. You remember the graph that I showed cumulative overdraft with an overdraft in the Prescott active management area of almost 1/3 of a million acre feet. So one gets to wondering whether that might have something to do with climate. And I know that there's some resistance to the idea that climate is changing, but I think there's some reason to believe it is, and it may be changing, may be involved in this decrease in that 7-day annual lowest flow. This diagram right here is a diagram by NOAA, annual mean precipitation in inches, 1895 through 2020 in Yavapai County. The red line is a 10-year moving average that I added to the calculated and added to the data. And this shaded area right here is the time from 1996 to the present. And it isn't terribly dramatic. We're in a low with respect to precipitation in this last quarter century, but it's no lower than it was for a large area in the middle of the 20th century. So by itself, it doesn't say, aha, here's the answer, but maybe it's a contributor to these decreasing 7-day annual flows. This is the same kind of thing, except this is mean annual temperature. And this knocks my eye out. So this is temperature degrees Fahrenheit. This is a record that goes back to 1895. So it's 130 years of record. And the last 25 years, and I labeled the data for 1996 just as something to register to in every one of these diagrams. It's in the last quarter century, we've been dealing with mean annual temperatures that are substantially above anything that, or almost anything that ever occurred in the preceding century. And I think that's important, and that it really has something to do with these changes that we see starting in the mid-1990s at these Verde River stream gauges. And I have to exclude the Oak Creek gauge from that. Oops, sorry. Let's go to the next here. So I thought, wow, I wonder whether we're seeing climate change in here. I kind of think that's what we're seeing. I think that change from to temperatures that are higher, pretty consistently higher in the last 25 years from the temperatures in the preceding century, may just tell us that we've entered the world of climate change. So this is from the Fourth National Climate Assessment. This was published in about 1918. And these are predictions of temperature increase in the United States. These are maps that are in that report. I show the approximately position of Prescott, just for reference in here. And those climatologists see by mid-21st century see likely increase of 2 to 3 degrees of Fahrenheit in the Prescott area. That would be this whole color band right here. And 4 to 5 degrees again in the mid-20s as a higher limit on, or another calculation. So average temperature changes of maybe 2 to 3 degrees, or maybe 4 to 5 degrees. By the late 21st century, they estimate about a 4 to 5 degree Fahrenheit change in the low temperature and 7 to 8 degrees in the late 21st temperature in their high temperature estimate. They're not making exact things. They realize these are estimates and they don't have complete control of how climatic controlling features will change. But these are the estimates that are published in the Fourth National Climate Assessment. They seem compatible with what we've seen in the change in temperature in particular from the last 25 years in our area. The next slide from the same report, Dry and Drier, is their analysis of change in precipitation. And these are for the late 21st century. There are divided by seasons: winter, spring, summer, fall, and there is I guess there's just one 21st century scenario represented here. About a 5% decrease in the Prescott-region in the late 21st century, minus 20 to 25%, a decrease in the springtime by the late 21st century, minus 5 to minus 10% in the summer, and 0 to minus 5 change in the fall. These are significant. One of the things about, it's not hard to imagine that decrease in precipitation would lead to decreases in the amount of groundwater and storage in the aquifer, leading to decreases in river flow and maybe eventually ending up with dry river flow. The role of temperature in this is that increased temperature significantly increases evapotranspiration. Evaporation either from water surfaces or increased use of water by plants trying to survive, and that's why increased temperature is a serious problem. So I'm not saying that decades and decades of climate change are on the verge, but it seems to me that in the last 25 years, it's definitely gotten warmer. It's gotten a little drier, and it's tempting to suggest that we're in a relatively early stage. Globally, it's more advanced in some places, but we're in an early stage globally of what might really be a period of increasing temperature and decreasing precipitation. I might add on precipitation that the report talks about episodes of relatively intense storms that would produce more rainfall. But as I read the report, these changes, 0 to 5%, 20 to 25%, et cetera, include consideration of the idea that there may be some stronger storms from time to time. So getting close to the end, and at the Citizens Water Advocacy Group, we're trying to think about a more appealing name than CWAG and the Citizens Water Advocacy Group. Would welcome suggestions. One that I remember was SOW, Saving Our Water, but there are others like that. Anyway, improving our water future. So, and this is just for the Prescott Active Management area, but would give things to think about. In the Prescott area particularly, we have reduced the use of groundwater for outdoor irrigation. Prescott actually has had quite a bit of success with graded rates for water consumption. If you use a relatively low level of water at your home, you pay a much lower rate than if you use a lot of water. They are very much aware of and trying to eliminate leaks And there certainly has been a growing emphasis and concern in maximizing water conservation in homes and businesses. So Prescott in particular is going in the right direction. I'm not sure everybody else is, but Prescott is. Other essential things for future efforts in the Prescott active management area are to eliminate the use of groundwater for outdoor irrigation, coordinate water, and this is really important and could have application in the Verde Valley as these issues are addressed. Coordinate water management among the 4 municipalities of the Prescott active management area, and include Yavapai County, because all of the land in the Prescott active management area that is not in one of the 4 designated municipalities is Yavapai County land. And to get anywhere, and I think the idea probably would apply in the Verde Valley as well, it's going to require a real effort and coordination among all of our local elected officials. Another one is to capture runoff from roofs and roads, parking lots, etc., for treatment and piped return to the aquifer system, return to the groundwater. And that has to be strategic, and it won't be cheap. It'll cost. But if we don't do something, we already have lost water in a number of homes, not in the municipalities, but in a number of homes in parts of the Prescott active management area. They've lost their groundwater. The water table has dropped. Their wells, they haven't been successful in deepening their wells. They're out near the west edge of the basin, of the groundwater basin. But boy, when you lose your water, it's a serious problem. I think the Verde Valley needs to be thinking about the same kinds of problems. One of the things that really helps in the long run and should help is the concern about the Salt River, that the Salt River project has for preserving their legitimate water supply. In terms of protecting the river, it's a bonus for the Verde Valley. If the object in the Verde Valley is to build communities of houses, then SRP's plans aren't wouldn't be as much appreciated, but we probably would face in the Verde Valley and also in the Prescott area that in some decades in the future, century perhaps, unless we can do something that we're not doing right now, people are going to start losing their water supplies and having to leave. And I think that's that's the end of my presentation. Thanks for listening, and I'll be glad to try to answer questions.
Thanks for that, Ed. I'm going to just step in. There are quite a few questions in the Q&A session. Do you have access to that?
No, I don't. You're going to have to help me with that. I don't see that on my screen at all.
Well, I'll go ahead and read it to you.
Okay.
In response to annexing Spring Creek Ranch land into the city of Cottonwood, the mayor indicated that the city of Cottonwood has actually decreased the amount of water used in Cottonwood due to repairing leaks and good water management. Adding Spring Creek Ranch with thousands of new residents appears to be a non-issue to the mayor and other city leaders. What are your thoughts about their comments?
Well, I commend them, and I commend Prescott as well for improving their management of the water. I think when you start adding big communities pumping groundwater, and in spite of the land that SRP controls, there's a lot of land that can be developed and provide groundwater from wells. You're going to start decreasing the groundwater supply, and eventually some people are going to lose their wells, and it isn't going to happen next year, but our grandchildren or great grandchildren are very likely to find themselves having to move out of this area because they don't have water unless we figure out how to manage both growth and the use of our water. Um, did I answer all of the question?
No, no, yeah, that one. There's more though. There's roughly 10 questions here. So let me
Yeah,
move
I
on
just
to,
wondered whether I had left something out in answering that one question.
I believe so. I hope so.
Okay.
Yavapai County Development Services continues to tell citizens that the county is prohibited from considering water when evaluating whether or not to approve huge new developments. Can you comment on this and whether or not the county is correct?
Well, I don't, no, I can't comment. I don't know. I know it has not been something they've done. I don't think that we can limit whatever we do over a coming century to what we've done in the past. We need to start taking new and more imaginative ideas, and that includes involving the Yavapai County Board of Supervisors in water management and water decisions, because even within the Prescott Active Management Area, a substantial part of the land that's within the active management area isn't in any of the municipalities, it's in the county. And we've got to get to a point where we're all involved in trying to manage the water for the long term, or else say it's hopeless, we'll stay here until our water runs out and then we'll go live somewhere else. Our
Okay.
choice.
Here's another question regarding the charts that you put up. Municipal water deliveries dropped after 2006. Do you know why?
Yeah, if yes, I know in part, and I don't know it isn't right at 2008. There are other charts that are somewhat similar that show a significant decline in water usage in 2008, and that was the time of the economic crash. And I looked at some population numbers that I could find, and the population also diminished at that time, and it shows up. I think the other thing that is a factor, and I can't quantify it at all, is that in some areas at least, we are actually getting to be a little more efficient in our use of water.
Well, that's comforting. So given the continual drop in the water table, what point in time will the groundwater no longer be available for use to pump?
Well, I can't really answer that question. I'll have to say, and it's definitely the case for the Prescott Active Management Area, but it probably is for the Verde Valley at large as well. We don't really know enough detail about the aquifer. We don't know how deep the wells have to be everywhere, and this is particularly true in the Prescott Active Management Area, because within the Prescott Active Management Areas, we don't have layers of rock like the red wall limestone that are somewhat predictable and are good aquifers. We've got volcanic rocks and alluvial deposits in a basin that is set into very dry rocks, granite and related rocks. And we don't know enough about the aquifer to really begin to answer that question. We know that there are good aquifer units within the Prescott AMA that are very productive for water, but there are also very fine layers of fine-grained sediment that they're full of water, but the water doesn't move easily in them. So the rate of water movement, which is critical, we just don't know enough to be able to answer that question. The other thing is we've already got some places within the AMA where people's wells are done. They can't accomplish anything by drilling deeper. They're near the edges of the basin, and they have to haul water or move somewhere else. And elsewhere, we don't have really great information to give precise estimates of when the water will run out. It's already begun to run out. And in other places, it's probably good for a century or more. I think the same thing applies in the Verde Valley. A good part of the Verde Valley is thick, several thousand feet of basin fill deposits, sand and gravel, and some volcanic rocks that rest on either Paleozoic sedimentary rocks or Precambrian basement, which is not a good aquifer at all. So we don't.
Here is a.
We can't say you have 123 years. We haven't any idea.
Okay. Here's a rhetorical question. Why are the governing bodies not held to abate development if overdraft exceeds sustainable level?
Well, I think it's, something that seems very evident is that an important part of our community mentality doesn't include all of us, but I think an important part, particularly among our elected officials, is business growth, making money, expanding our population. I think they feel, and I think the voters seem to support it, that that's what they should do.
Okay. Okay. So one viewer here noticed that 7-day low flow values are lower at Camp Verde than at Clarkdale. Is this due to removal for irrigation or other uses?
I have any idea. My recollection without going back and looking at the diagrams is they're really not very much different between those two places. They're much lower. The numbers are bigger than at the Paulden gauge, but the amount of water in the river at the Paulden gauge is much smaller.
Okay. Here's one a question. It's somewhat complicated. Both BOMA and ASU researcher Dr. Kevin Murphy stated on AZ Horizon on June 25, 2020, that we have been in a drought for 25 years, which is consistent with what you had pointed out. They insinuated that the drought will end and the rain will return. In fact, they said when it returns, there will be a dramatic increase in rainfall due to changes in the atmosphere. You mentioned episodes of increased rainfall included.
Did they put a date, a time frame on when this dry period will end and we'll be living in a green paradise?
If they did, it's not in the question that I mentioned.
Okay. I get the impression, and I think this fourth climate work looks way into at least a century of increasing temperature.
Okay. Okay. So has the Prescott AMA decided on a safe yield withdrawal rate?
It has never been in safe yield, and I think there's very little chance of being in safe yield. It's not very effective. It's kind of unmanageable. So I think the answer is we're not making any progress in that direction.
You referenced an 8,000 acre feet diversion of water into Prescott Valley. Is the drop in flow in '96 caused by that?
No, that hasn't happened. It's there has been legislation that has authorized it, and within the last decade, I can't remember the year, but anyway, there was a tremendous amount of court activity, challenges to the idea of that, and it finally got resolved. I think it was in part it was SRP against Prescott and Prescott Valley, and I think both sides of that argument decided they were just spending too much time and money, so they came up with a plan that the three signed into, Prescott Valley and SRP, to try to resolve the problem, and that one of the elements of the problem, one of the conditions that SRP, I'm sure, added to the mix was if they were going to export that water, they had to do it without lowering the discharge of the groundwater into the Verde River.
Okay.
As measured at the Paulding stream gauge.
Okay. So here's a question about somebody who wants a practical application of what your presentation was tonight. And they want to know if it's better to keep water running off roofs on your property with depressions, ground depressions, or just allow it to run into washes so it can eventually get to streams and percolate the groundwater.
Well, I guess either one is a strategy. I think one of the things we may want, I'm not sure that I could say it makes a big difference which way you do that. I think that one of the things we may need to contemplate in the future, and it isn't going to be free, is actually capturing water from roofs and roads and such areas, parking lots, and treating it as necessary to make it appropriate to re-inject into the ground in a strategic place. One of the problems we have is Prescott, for example, treats its wastewater and returns a portion of it to an infiltration basin near the Prescott airport. And they get credit for that water. But the problem is it probably would take at least a century for the water that they return to that those basins to reach the area in Chino Valley from which Prescott pumps its groundwater. So it's not perfect, and it's a move in the right direction. And I think one of the things, if we really get serious, really want to be able to live here in perpetuity, we're going to have to figure out how to maximize capture of water and transporting it and injecting it in strategic places.
Okay, there's a listener here that's trying to calculate the residential consumption of water per person per day in the Prescott AMA. Do you know the approximate population?
No, I could find out, but I don't have that one in my head.
Okay.
There's been quite a bit of thought about that and improving it, but I don't have the number in my head.
Okay, so another person here wants to suggest that municipalities should require stormwater infiltration structures. Does that make sense?
Yes, it depends on, I think that makes sense, but some places will be more effective in the long run than others, and that kind of thinking needs to be considered as well.
Okay, how far out have you computed numbers? Somebody here is interested in knowing the last year, and particularly the last 3-month forecast from here. Do you keep up with this? Is something you keep track of
No.
monthly or?
No, I don't keep track of it at all. The sort of things I kept track of, looked up and tried to make sense of are exactly what I've talked about, but I don't keep track on a short-term basis at all.
Okay. So the draw you mentioned is roughly 22,000 acre-feet per year. What does that translate to in terms of rainfall in inches to meet that?
I don't have it. I don't have an answer to that, and it's a complicated question because a lot of the rainfall gets consumed by vegetation, or it runs off to somewhere else, or it just evaporates. And it's not a simply answered question. I don't have an answer for it. I mean, I'm sure there are people who've thought about it, but I'm not one of them. Not that I don't think it's important. I just, I've only got one brain.
Okay. So a question here about fracking. for natural gas and helium under the White Mountains, would it possibly increase the aquifers or decrease, or does it have any impact on the Verde Valley water?
Well, I suppose that layers at tremendous expense, that layers within the aquifer that have low porosity and low permeability, they're fine-grained layers that have very small spaces. They have a lot of water in them. In fact, they tend to have maybe the highest volume of water per cubic foot, but the water doesn't move easily. It moves so slowly that it's not suitable to, or not very effective in returning water to wells. In the Prescott Active Management Area, we speak of two aquifers that are separated. One, well, two of them with a fine-grained unit of fine-grained sediment between them that impedes the movement of water. And the better wells actually are in the municipal wells are in the lower of those two layers. It would be an incredible task to try to turn a widespread area of very fine-grained sediment, maybe 100 or several hundred feet thick, into a productive aquifer. I mean, mechanically to change it. I don't think that's coming soon.
The flip side of that is the fracking going to put the aquifers in the Verde Valley at risk?
I don't know if it really worked and it were a way to increase the production of water, you would just be dewatering the aquifer faster than we're doing it now.
I suspect the question is related to potential damage to the aquifer that would then poisons the pollution that would, as a result of the fracking, would is it possible that it would damage the
well, I don't know when fracking is said. It's usually applied to getting at oil or gas in rocks that contain them. We don't have rocks that contain petroleum or gas within our local aquifer systems. So the questions I assume had to do, could you do something like fracking to increase the water moving capacity of the aquifer? And maybe you could, but you can't increase the amount of water entering the aquifer by doing that.
Okay. Last question. With the 7-day low flow water pattern in Sedona, is the water situation in Sedona less of a concern than other 3 areas of the Verde Valley?
Well, I don't know the answer, and I don't have a good basis for saying. I was quite surprised that I didn't see something that resembled that pattern at the Sedona gauge. And we're talking about one point in a vast area. I didn't see that pattern, and I'm just guessing that it could be related to the proximity of the Redwall aquifer, which is a really important aquifer in this part of Arizona, not in the Prescott Active Management Area, but in the Verde area and some of the country close to the Verde. And it may be that really changes the ball game just because, but I don't know that. I'm just trying to make up a hypothesis based on something I do know that might offer an area for explanation. I was really surprised that it was so different.
Yeah. There are 2 more lake questions here. The fracking questions were related to activity in the Holbrook area, not the Verde Valley. So that I don't know
Oh.
if that would change your response or not.
I don't know enough about the Holbrook area. I spent
Okay.
14 years as a geologist in Flagstaff with the USGS, but I didn't do any work off in northeastern Arizona.
Okay. And here's somebody who lives in Cornville that wants to learn more about the state of the aquifer in their area to help them understand how the proposed Spring Creek Ranch development would affect their water source.
I can't answer that, and it takes a hydrologic study, not somebody who really hasn't done a detailed hydrologic modeling, groundwater modeling study to answer that. I'm not that person, and I haven't done that kind of work, and I wouldn't begin to try to answer that question, just because I don't know how to answer it.
Okay. I think that's we're ready to shut down here, Ed, and I want to thank you. It was very interesting, and I'm glad you made the time for us. And there were several other comments that I didn't mention that people said they liked CWAG was one of them, and as an acronym, and that also they thought it was a very good presentation. So I just wanted to pose that to you.
Thanks to them. I appreciate that comment, and thanks to you. I enjoyed doing it, and we'll do it again sometime. It'll be different a year from now, probably.
Okay. All right. Sounds good. Thanks, Ed.
Okay. Thank you. Bye.
Bye-bye. Bye-bye.